Hey guys, Al here. So I want to talk about something. There were some comments on a post, and all good stuff. I always like when people challenge and ask questions. As long as it's done respectfully. I think that's how we as a society will grow for everyone to have a better understanding. And if it helps me to say, am I doing a good job explaining, my thought process on how I understand something, right? My comprehension of something. So that led me to want to dive into this 6 slide little overview of, really what is an organic nutrient? Why do nutrient forms matter? And like, why does that matter when we're talking about, like, say, no-till nurture or manure versus, say, a synthetic addition like potassium chloride or ammonium sulfate or ammonium nitrate or something of that nature. So an organic nutrient, by definition, is going to be a nutrient that has a carbon molecule. Although there are some nuances there. In this particular example here, you'll see that I have a example of a urea molecule, which is going to be, by most soil scientist definitions, I would imagine they would say it doesn't really act like an organic nutrient because it's already pretty far along in the process and there's only a couple bonds and it breaks apart pretty quickly, which is why urea is so inherently volatile. So I wanted to go in a little bit further and explain. So here you'll see the feather meal protein, and this is really what we kind of typically think of when we're thinking of organic nutrients. So just without knowing anything about chemistry, you can just see the pure number of bonds there and what needs to take place between microbial digestion and the breakdown into peptides and things like that. So you go from protein to peptide chains to amino acid, I believe I got that right, into plant available forms to where then they are assimilated by the plant. So why does that matter? Well, that matters. The nutrient form matters because simple molecules, synthetics, things like that, or in the case of urea, which again is kind of nuanced, but they're already in plant available forms. They're going to activate quickly, but that comes a risk, higher risk of plant burn, potentially higher stress to the plant, potentially osmotic stress, depending on if it's a salt form or not. So again, there's examples of urea, ammonium nitrate, potassium chloride, all kind of react that way. Also the risk of leaching, or in the case of, like, say, phosphorus, you're going to have the risk of immobile nutrients. So when you talk about organic forms, again, going back to that idea that it's an organic nutrient that is attached to a carbon molecule, these nutrients are going to be based by carbon chains like you saw in the feather meal example, or feather meal protein example, I should say. So that's a complex protein or complex molecule. It's going to require microbial digestion in order to break down, in order for that to be those nutrients to be released. So obviously, as you can see in that chain, you wouldn't expect that thing to all just break down simultaneously. It would break down in parts relative to temperature, rainfall, microbial density, things of that nature. That's going to then slowly release those nutrients. So examples here are feather meal, but we also put on this chart, blood meal, manure, plant residues, all of the things that we think about when we're thinking about, the Vitalize 1-2 system, or if you're looking at organic nutrients for your garden, or you're drilling into a rye grain field for corn or bean production. That's all in organic forms that are going to slowly release. And there's other benefits to that, but just for the sake of time, that are going to slowly release those nutrients that those plants had sequestered over the growing season, are now terminating and releasing those nutrients slowly into the soil so that next crop can take advantage of that. That's why it's important, because it's organic form that's like a slow release fertilizer. So why is carbon helpful? Well, it feeds biology, right? So we talk about a lot at Vitalize Seed, understanding carbon and nitrogen ratios. So too much carbon isn't necessarily a good thing, and obviously too much nitrogen isn't a good thing, and that balance is really important. And microbes need so many parts carbon to every part nitrogen. So having molecules that are in organic form, slow release, better movement, slow uptake, which means you lose less of the product, right? You don't have to put down 300 pounds in hopes to get 100 into the crop. You can be a little bit more intentional with the product, because it's going to be slowly released. You don't have to necessarily time it with rainfall. Of course, that's beneficial to get that immediate burst. that carbon is going to help to build the soil health. It's going to enhance nutrient cycling. Well, why? Well, because your microbes are unlocking nutrients that are already in the soil. So as those microbes are propagating, they're getting fed, right? They're propagating faster. Well, there's other nutrients that are in the soil. So the plants are growing, which are then unlocking additional nutrient channels, right, or pockets within that soil profile. And then it's going to obviously support long-term fertility by helping to increase microbial stability, soil aggregation, feeding soil biology, etc. So one of the things we talk about a lot is phosphorus. So phosphorus is an extremely important root structure, ATP, within the plant, which is like an energy transfer within the plant. However, phosphorus tends to be really immobile. So there's a lot of good science out there that talks about phosphorus being in huge amounts in our soil, more than we'll ever use or more than we'll use in 30 years without ever adding any. The problem is not how much is there, it's how much is available. And there's been a lot of tests that show throwing phosphorus on top in synthetic forms, specifically without cover crops and specifically in no-till systems, causes problems. So that doesn't mean, we just go to till everything. Certainly tillage can work, and we can talk about that. And specifically, if you're putting a lot of carbon back into the system, you can kind of mitigate some of the issues that tillage causes, breaking up aggregation and things like that. However, if you're in the no-till systems, like we are most of the time at Vitalized Seed, or at least on my farm, using organic forms of phosphorus, so whether it's plant residue or a no-till nurture product, that worms and microbes are going to consume and move through that soil profile naturally, so they get into that root zone, where then the next plant or next crop or next root that hits that is able to then take it up. So, what is nutrient stratification? Honestly, it's just a kind of a fancy way of talking about nutrients getting separated by either improper forms being used or just typical growing practices. So it would be like if in the top 2 inches of soil, you might have 500 pounds of phosphorus, and then everything below there is lower and lower and lower, right? Getting diminishing rates. And you're planting everything, say at 2 inches, and everything's in the top 1 inch. Well, that would be a problem, right? Because you're not going to have the available phosphorus. Now, will the plants get to it? Possibly. And if you're in a row crop system, you can do in-furrow things, and there's a lot of neat things you can do. But a additional option with all of those when working on soil fertility is one, partnering things with, not only if you're going to use synthetics, if we're saying row crop farming, we got to pay our mortgage, we're going to probably use some synthetics in furrow and timing the placement, whether it's in a Y drop or something like that. That really depends on soil type and what we're trying to achieve, but also using cover crops in a lot of cases, and also making sure that if we are putting phosphorus down, it's getting into that root depth. In the case of phosphorus, of course, if it's nitrogen, we want to make sure that it's getting to the place with good rainfall. If it's in synthetic form or irrigation, synthetic form or irrigation is helping it to get down to the plants. That's why a lot of times you'll see the old Y drop setups, or even old school farmers and gardens will say, we got a rain coming. They're throwing down ammonium sulfate or urea by hand in between all their tomato plants. But all is not lost. So one of the things you need to consider too is do synthetic fertilizer work? Absolutely. But like with everything in soil, it all comes back to balance. So if you're just constantly throwing out, hey, I got a good response from ammonium sulfate or a good response from XYZ synthetic input, that doesn't mean that more is going to be better. If there are salt-based fertilizers, which many can be, and again, salt-based by the chemistry definition, you can increase the salt load on your soil, which can create osmotic pressure. So what that basically means is, instead of the roots being able to pull water in, you're actually creating osmotic pressure that's going the other way. So you're actually drying your roots out because of that additional salt load based on the salt chemistry and osmotic pressure changes in soils that are heavily reliant on salt. You also see less plant root exudates, which helps or can reduce your microbial stimulation within the soil profile, which can reduce, not always, but it obviously can reduce in certain situations, again, soil aggregation and things like that. So that's why when you look at all of these things, and we talk about no-till nurture, we don't expect no-till nurture. You can't just throw it out on your driveway and expect something to grow. But it's one part of the system, of the Vitalized system or garden system, on top of sound agronomy, sound soil health, sound soil testing. And hopefully this helps you guys to understand a little bit more about what we're talking about when we're talking about either a no-till nurture product or residues that we're drilling into and laying over, and how those organic nutrients are helping to feed your soil health journey. Check us out, vitalizedseed.com.